One formula decides whether your pool eats itself alive or chokes on calcium deposits. It was invented almost 90 years ago for cast iron water pipes. And it's still the most important number in pool chemistry. In the early 1930s, American water utilities had an expensive problem. Their cast iron pipes were either corroding from the inside, releasing rust and lead, or clogging with calcium scale. Sometimes both problems existed in the same system. Enter Wilfred Langelier, a sanitary engineering professor at UC Berkeley. He was not a pool guy. He studied municipal water treatment. But his 1936 paper would become the most important formula in pool water management. His insight was elegant. Calculate the theoretical pH at which water is in perfect equilibrium with calcium carbonate. The pH of saturation, or pHs. Then compare actual pH to that value. LSI equals pH minus pHs. If the LSI is positive, the water is supersaturated. It has more dissolved calcium than it can hold, so it deposits scale. If the LSI is negative, the water is undersaturated. It's hungry for calcium carbonate and will dissolve it from any surface it touches. Pipe walls, concrete, plaster. Langelier built on established carbonate equilibrium science. Calcium carbonate dissolves in water governed by a temperature-dependent solubility constant. The key insight: as water gets hotter, calcite becomes less soluble. That's why scale forms first in heaters. The formula uses 5 measurable factors. pH, the one you adjust most. Temperature, hotter means less soluble. Calcium hardness, total alkalinity, and total dissolved solids. Langelier knew operators wouldn't solve thermodynamic equations in the field. So he converted the math into lookup tables. Each factor gets a pre-computed value. You may add them up, subtract a TDS correction, and you've got your index. No calculators needed, just tables. Let's work an example. Pool at 84 degrees, pH 7.5, 200 calcium, 100 alkalinity, 900 TDS. Plug in the factors. 7.5 plus 0.7 plus 1.9 plus 2.0 minus 12.2 equals negative 0.1. Within the balanced range, no action needed. Now raise that same water to 105 degrees. Spa temperature, the LSI jumps to positive 0.1. Same water, same chemistry, but the higher temperature shifted it from slightly corrosive to slightly scale forming. That's why spa heaters scale up first. The pool industry adopted LSI through the 40s, 50s, and 60s. The post-war pool boom created millions of plaster surfaces needing balanced water. Equipment manufacturers needed chemistry standards, and the CPO training program needed a quantitative method to teach water balance. When LSI goes negative, the water becomes aggressive, it etches plaster, corrodes copper heat exchangers, leaches metals that cause staining, and roughens surfaces that harbor algae. When LSI goes too positive, calcium deposits everywhere. Scale coats heater elements, clogs salt cells, narrows pipes, and creates white deposits that cloud the water. The accepted balanced range is negative 0.3 to positive 0.3. That's your target window. Within this range, the water's tendency toward scale or corrosion is negligible. Outside it, damage accumulates over time. Yes, different surfaces respond differently to LSI imbalance. Plaster pools actually benefit from slightly positive LSI around plus 0.1 to plus 0.3 because a thin calcium layer protects the surface. Vinyl and fiberglass shells are unaffected by calcium, but their metal components still need balanced water. Want to calculate the LSI for your pool right now? Check out the free water balance tools at PoolDial.com. Plug in your numbers and get an instant reading. In 1944, John Ryznar published a competing formula. RSI equals 2 times PHS minus pH. Ryznar predicted the magnitude of scale or corrosion, not just the direction. Industrial cooling adopted Ryznar, but Pool stuck with LSI. Direction matters more than rate. Langelier acknowledged the limitations. LSI only considers calcium carbonate, not magnesium or phosphates. It assumes equilibrium, which pool water rarely reaches, and it ignores flow rate. Like, the same LSI causes more damage in stagnant water than in high flow pipes. Langelier died in 1982, but his formula remains the standard. The PHTA's CPO handbook covers LSI in Chapter 6, and it appears on every certification exam. The thermodynamics don't change. Calcite works the same in water mains and backyard pools. That's the Langelier saturation index in 1936 formula that still governs pool water today. This was part 2 of 5. Next, cyanuric acid, the chemical that changed pool chemistry forever. Subscribe so you don't miss it.